All right, here we are going into section 2.5, which is going to be a very, very important section, and I apologize, it might be a little bit lengthy on here, but it is very important for us to realize this. So there's a lot in this section on transformations of functions. So let's get started. Knowing patterns of transformation of functions is so important. So we're going to talk a lot of patterns here with equations that we look at, not only with square equations, but square root equations, absolute value equations, etc. Knowing that graph, that a graph is a transformation of a familiar graph makes graphing so much easier. So here's our common graphs that we look at. If we have a constant function, that is going to be where we have f of x is equal to some c value. So I choose some c, I'm just putting that here, that's c. A constant function's graph is a horizontal line at that c value, okay? So that's the most basic, The identity function, which is also our linear one, is f of x is equal to x. Now remember, we can write that as y equals x if we want. F of x and y are the exact same thing. That linear function is y equals mx plus b, where m is 1, b is 0. So if I start at 0, go over 1, or up 1 and over 1, up 1 over 1, I end up getting this line that actually kind of bisects the first and second quadrant, and that is our linear identity function. A lot of times when we do lines, we do resort back to the y equals mx plus b and graph it. So a lot of these patterns don't even work so much with the idea of a linear function, because we can just do it easier with the y equals mx plus b. Now, our absolute value function is f of x is equal to, the most basic is the absolute value of x. Now, if we look at doing some of these t-charts, and these are going to be important for you to work with a little bit as well. If I throw each one of those points into this function, the absolute value negative 2 is 2, of negative 1 is 1, 0 is 0, 1 is 1, and 2 is 2. So when I graph those points, we're going to get kind of what we call the apparent function of that absolute value. Now, we've seen absolute value functions before, and it is a v. So you want to make sure anytime that you have a function with an absolute value that you kick out one of these v shapes. Okay. One we use over and over and over is this quadratic function, okay? So our most basic quadratic function, y equals x squared, or f of x equals x squared. And so I'm going to do a t-chart on here that's going to be very, very helpful. Again, when you throw each one of these into our function and square it, when I square this one I get 4, I get positive 1, 0, 1, and 4. The graph of that y equals x squared, or f of x equals x squared, is that parabola that we have, and I refer to that as our U shape, where we ended up talking about kind of some minimums here within those. The chart here is going to be very, very important later on. Okay. For our square root function, f of x is equal to the square root of x. And I apologize that the first page is just basically here's what we have. For our square root function, the values that I want you to throw in for your square root function are going to be 0, 1, and 4, because when I throw those in, I get nice whole numbers out when I square root each one of those. So the graph of a square root function, here's 0, 0, over 1, up 1, gives me that point, over 4 and up 2 gives me that point. So the square root of x is actually kind of looks like half of this one turned on its side. So if I take like this portion and I turn it on its side, it's going to look just like that square root function, okay? So having that t-chart there to help you is going to be very, very helpful when we start transforming. For a cube root function, cube root, I did say cube root function here. I got a typo. Let's make that a cube function. Sorry, let's do the x cubed first. Let's do f of x is equal to x cubed. And the points that we have, if we look at negative 2 to positive 2 on the integers, and I cube each one of those because that's what my function tells me to do, I get negative 8, negative 1, 0, 1, and 8. So obviously negative 2, negative 8 is way down here somewhere. Negative 1, 0, 0, 1, 1 is this point, and 2, 8 is up here somewhere. And so what I get is kind of a squiggle function is what I call it. And that is my x cubed. So anytime you have a function with an x cubed, your graph should look something like that. Again, make notice of that chart because that's going to be helpful later when we start transforming. And our last one is actually the cube root function. I'm going to do that as the cube root of x. And this is the inverse of that x cubed function. So it should look very similar. Now, if you remember, inverses, we swap the points, okay? So if I do -8, -1, 0, 1, and 8, and I cube root each one of those, I chose those numbers because I get nice answers when I cube root them. -8, -2 is going to kind of be down here. -1, -1, 0, 0, 1, 1, and 8, 2. Now, notice, oops, maybe we go up there. Notice that these 3 points are the exact same in my x cubed as it is with this cube root. So be very careful there with that. Okay? All right. So those are my 7 basic functions that I have. The 5 that you're going to actually, there's about 4 that you're going to be working with most often is the absolute value one, and then these 3 in this row. Not a lot of times do you see the cube root, but sometimes it might come into play. Okay, so let's talk about our first transformation. Our first transformation is going to be time to investigate a vertical shift. Okay, so I'm going to graph this guy using a t-chart and see what I can get see what happens when I compare it to the original y equaling x squared. So I'm actually going to kind of remember that was here, 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 and here. So I'm going to basically take that x squared and just kind of put it on there, and let's see what we get when we throw in these numbers for this function right here. So I'm going to square -2 and then add 1. -2 squared is 4, add 1 is 5. -1 squared is 1, add 1 is 2. 0 squared is 0, add 1 is 1. 1 squared is 1, plus 1 is 2. And 2 squared is 4, plus 1 is 5. When I end up graphing -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5, I get this parabola. Now, what did I do to each one of those points in order to get my new parabola that I have? Well, I'm hoping you say that they're all moved up 1. That one's moved up 1, that one's moved up 1, this one's moved up 1, and that one's moved up 1. Okay? Now, what happens when I have x squared minus 3? Okay, so when I, again, go ahead and put that original parabola. We get 1, 1, 2, 4, and then we get matching points because it is an even function that's symmetric over the y-axis. So there's that. Now, what happens whenever I throw in the same values into that function? I square them, and then I subtract 3. So -2 squared is 4 minus 3 is 1. -1 squared is 1 minus 3 is -2. 0 squared is 0 minus 3 is -3. 1 squared is 1 minus 3 is -2. And 2 squared is 4 minus 1, or minus 3 is 1. So if I graph -2, 1, then I have -1, -2, then I have 0, -3, then I have +1, -2, and +2, 1. I end up with this parabola. Whoops, I think I'm off just slightly. I can't see that. Let's see, let's try that again. All right, I get that parabola. So what happened to each one of my points? From here, I went down 1, 2, 3. From here, I went down 1, 2, 3. That gives me a transformation of down by 3. This one, we went up by 1. Now that it all comes from that number that is added or subtracted at the end. So hopefully you recognize that. So when we generalize for a vertical transformation, then we are going to let f be a function and c be a positive real number, then the graph of y equals f of x plus c takes the original graph up by c. Then y equals f of x minus c takes the original function down by c. Okay, so anytime you have a plus or minus at the end, that is a vertical shift up or down by that c value. Okay, so let's look now, before we kind of move things together, let's look at a horizontal shift, okay? Now, I'm looking at this point here, okay? If I want to graph that, I'm going to use a t-chart of my values of -2, -1, 0, 1, and 2. And if I throw that in there, -2 minus 2 is -4 squared is 16. When I put -1 in there, I get 9. 0 is 4. 1 is 1, and 2 is 0. So if I were to graph these points, obviously these first two are off the chart. 0, 4 is here. 1, 1 is here. 2, 0 is here. Notice I don't even have all of my parabola. So if you don't see that U shape going on your parabola, keep going and finding some values. So if I add 3 and 4 into that, when I plug 3 in here minus 2 is 1, 1 squared is 1, 4 minus 2 is 2 squared is a 4. So now I get the point 3, 1, and that looks much better because right there is my parabola. Now, what was the original parabola? Hopefully you're getting used to it. The original parabola did something like this, okay? Now, what happened to this new parabola? Here's my vertex. It moved over twice. Here was this point. It moved over twice. So this we move to the right by 2. Now, if I do a t-table for this guy over here, and I choose -2, -1, 0, 1, and 2, just by plugging in those values, I will tell you, you get 1, 0, 1, 4, and 9. So if I plot those points, -2, 1, -1, 0, 0, 1, and 1, 4, obviously 2, 9 is going to be off the charts. It's up here. Now I kind of look like I have a U shape going, which hopefully this is going to be my turnaround point down here. So if you need to throw in another number, say at -3, plus 1 is -2, squared gives you a 4, you can do that, okay? But you can also finish it on your own if you know about that symmetry. So here is that function. Now, the original, again, is where? The original did something like this. So, what did I do from the original? I moved it to the left one. Now, notice if I went to the left one in my equation, it has a +1, so it's opposite. When I look to the right 2, it is the -2 in the equation, so it's kind of the opposite of that. You have to change the sign. So in general, for our horizontal transformation, we're going to let f be a function and c be a positive real number. Then the graph of y equals f of x minus c, that's the minus one, we move the original right by c. And if I have y equals f of x plus c, then it takes the original left by c. So that's this guy right here that we found. So it's kind of opposite. When you're grouped with the x, things are opposite. So let's see if we can, by just looking at this equation, can I graph this? An absolute value, if you recall, looks something like this. Okay, you have to know those original functions. This in my equation is a -4 at the end. That is our vertical transformation. And we take the sign as is. So this means we're going to go in the negative direction 4. So we're going to take this original and we're going to bring it down 4. So I'm going to go down 4. If you recall, we can over 1 and up 1 kind of gives us those points of that original absolute value. Okay? What you can also do is do that original, we'll do this sometimes. If you do the original absolute value which would be a 2, a 1, a 0, a 1, and a 2. You can look on the back side to see that. You can also take that original value and subtract 4. So if you subtract 4 here, we get a negative 2, here we get a negative 3, here we get negative 4, here we get negative 3, and here we get negative 2. Okay, so that will actually give that to you as well, okay, for some of those points. Okay, easiest way is to know the original graph and then be able to move that down forward. Now, my original graph here is the square root function. If you remember, the original square root function were these points. Again, look on the other side. If you have forgotten, that's the original square root. And so, this is an x plus 3. So this goes back to where I'm grouping with inside my x value. This is going to warrant a horizontal shift that we have to take the opposite of what I'm looking at inside there grouped with the x. Well, here's a plus 3. That would be a minus 3 that's opposite of that. So that means I need to take this in the negative direction by 3. So this is going to be a shift of left by 3. So over 3, 1, 2, 3 now gives me this. The original function means I go over 1 and up 1, and over 4 from that vertex point, 1, 2, 3, 4, and up 2, 1, 2. That's what's important about knowing those charts, because it kind of comes from that reference point where we're going to go over 1 and up 1, or over 2 and up 2, etc., etc. Okay? Now, this next one is a parent function of an x cubed, and I need an f of x in there. So let's do like f of x equals, another little typo there, sorry about that. So if I'm grouped with the x, this gives me my horizontal shift that I take the opposite of this. So that means that I'm going to go to the right 1. Opposite of that is a positive 1 in the right direction. Anything plus or minus at the end is my vertical shift up or down. If it's a plus 2, that means we're going to go up 2. We use that same sign as is. So the original function for that x cubed was that squiggle, okay? It went through the origin. But if I go from the origin, go over 1 and up 2, that gives me my new point there, okay? So here was the original points on the original x cubed. Oops, negative 8. Okay, so here, if that's my origin, then this tells me I'm going to go in the x direction 1 and up 1. Over 1 and up 1 gives me my new point from my new origin point. Then we're going to go left 1 and down 1 to the new point. Then I'm going to go over 2, 1, 2, and up 8 gives me that point approximately up there. From the origin, we're going to go over 2 and down 8. 1, 2, 3, 4, 5, 6, 7, about there. And I'm going to create that squiggle, and that's going to be my x cubed function that I have there. Okay? So, anything grouped with the x, anything is a horizontal shift. You take the opposite of what you're looking at inside there. Anything added or subtracted at the end, we are going to shift up or down by that amount. All right, now we get to talk about reflections. Reflections are those that flip over an axis. So we're going to look at reflections over the y-axis and reflections over the x-axis. So if I want to try the graph f of x equal to negative x squared to see what happens. Now the positive x squared looks like this. You're going to get very familiar to that. That's very similar. And so if I want to do a t-chart with this guy, negative 2, negative 1, 0, 1, and 2, if I throw that in, square it, and negate it, then I get negative 4. Negative 1 squared is 1, negative is negative 1. 0 squared is 0, opposite of 0 is still 0. Then I get a negative 1 and a negative 4 again there. So, the new graph that I have, negative 2, negative 4 here, negative 1, 0, 0, and 1, negative 1, and 2, negative 4 gives me this graph that's right here. Okay? So, what we have here, if I have a negative out front, what we've just done is reflected this graph over the x-axis, okay? So the y-coordinates end up being opposites of each other, making this a reflection over the x-axis. And in general form, the y equaling the opposite of f of x is, actually take that is out. The graph of y equals negative f of x reflects the original graph over the x-axis. Okay? All right, very good. Now, what if I bring the negative on the inside of that square root, okay? Now, the original square roots that we had were 0, 1, and 4 on the x values. But here, we're going to look at, what if we had 0, 1. If I throw 0 in there, the opposite of 0 is still 0, square root is still 0. So I'm still going to go through this point here, okay? The original square root function, if I do the square root of x, if I went over 1, we were at 1. Over 4, we were at 2. So this is the original x squared, or square root of x. But if I throw 1 into this g function, what's the square root of negative 1? Hopefully you tell me I, but in the real numbers, I can't do that, okay? So what I need to do is change my things. Let's do a negative 1. If I throw negative 1, the opposite of negative 1 is positive 1. Square root of positive 1 is 1. If I try a negative 4 this time, negative 4 would be, the opposite of negative 4 is positive 4. Square root of that is going to be a 2. So if I graph negative 1, 1, negative 4, 2, now from this original, what I have now done, whoops, I'm going to solid that. Now what I've done is actually reflected that over the y-axis. Each one of those is a reflection of the y-axis. So the x-coordinates end up being opposites of each other, making this a reflection over the y-axis. And the graph of y equals f of negative x reflects the original graph over the y-axis. Okay? All right. So those are important. Most of the time we'll see a reflection over the x-axis. There's only very minimal ones that we see a reflection over the y-axis. But it happens. Okay? All right. Now, let's look at these. If I have the opposite of the absolute value of x, okay? Absolute value of x was here, 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 and here. We had that. So from here, I can also do that same thing. The negative is out front. This is an x-axis reflection. So that means that I need to now take this 1, 1 point and bring it down here. So this is like my mirror. So I'm going to mirror image it over here to this point. 0 is not going to be mirrored. This point's going to be mirrored over here. This point's going to be mirrored down here. So it is going to now have a reflection over the x-axis, and those are my points. Now, and by all means, you can definitely plot points on all of these, but I think the patterns are so much easier. So the solid piece here is my graph. You don't have to put the dotted on there at all. Now, what do we have here? When I have a negative x inside there, that means I have a reflection over the y-axis this time. And so you might need to make sure that you end up knowing your original function still. This is that cube root of x. So the original cube root of x ended up being 8, 2, negative 1, and we had negative 8, negative 2. So it looks something like this. Okay, so if you need to start with the original, please do so. Now, if I reflect each one of those over the y-axis, obviously this one's not going to reflect over. Here is my original point over the y-axis now becomes that point. And this 8, 2 now becomes over here at negative 8, 2, which is about there. This negative 1 now goes over here. And this negative 8, negative 2 now comes over here to positive 8, negative 2. So the x values of those coordinates change to their opposites when we're doing a reflection over the y-axis. So that would be our graph there. Okay? All right, very, very good. So let's see what happens when we put it all together. We have a negative out front, which means we reflect over the x-axis. We have a plus 2 inside here grouped with our x, which is our horizontal shift. Do the opposite of that means we're going to go left 2. Instead of almost like we have to add 2 to the right, but no, we have to do the opposite and go this way. And here we have a plus 2, so that means that's our vertical shift. where we are going to go up to in that sense, okay? So the original graph started at 0, 0. We had 1, 1, 2, 2, negative 1, 1, and negative 2, 2. This is the original, okay? I'm going to take that and I'm going to go left 2 and up 2, but then reflect it over the x-axis. So I get this new point. Okay, that's my new vertex or my turnaround point. If I do this point, I'm going to go left 2 and up 2 and then reflect that over that y-axis or the x-axis. Okay? Now, you can also, once you know that turnaround point, you know that you're going to go over 1 and up 1, over 1 and up 1, but when I reflect over, it's now going to be like an upside down V. So I can always kind of do this idea as well and fill in my points, but you can also do it with the method that I was just showing you there. I'm going left 2, up 2, and reflecting over the x-axis, and that's going to give us our values for that. Okay? All right, I know this got out there, but stick with it. You're going to be able to be pros at this by the very end, so we just got to have to kind of keep working at it, and the more we see, the easier it gets. Our next transformation has to do with vertical stretching and what we refer to as shrinking. Okay? Now, if I have this graph, we're going to let f of x equals 2x squared and g of x equals 1/2 x squared. Now, I'm going to kind of talk to you about this. If I do the original parabola, negative 2 squared is 4, negative 1 squared is 1, 0, 1, and 4, okay? What I have here is that's that x squared, and what I'm doing is really just timesing that by 2. So it should make sense that if I times all of these by 2, then I get my new graph, okay? That's why working with those charts are very, very important. So you can now go negative 2, 8, which would be up here, negative 1, 2, 0, 0 is the same, 1, 2 would be here, and 2, 8 would be up here somewhere. And what I've now done is basically kind of squashed that parabola. I've squashed it in, I've vertically stretched it, and so that gives me a more narrow graph that I have. Now, if I look at that x squared, again, I'm going to look at that parent graph, x squared, and I'm going to think about those original points. If I square each one of these points, I get 4, 1, 0, 1, and 4. Now, that is this piece, but this function tells me I now need to take half of that. So half of 4 is 2, then I get 1/2, then I get 0, then I get 1/2 again, and then I get 2. So now I have points that I can plot. Negative 2, 2, negative 1, 1/2, 0, 0, and 1/2, and 2, 2. So what we now have is a vertical shrink within this, where I say it gets wider, it gets fatter, or we squash it down a little bit. This would kind of be the original here, okay? So it's kind of on the outside of the original. It is a little bit wider, okay? So we are going to let f be a function and c a positive real number. If c is greater than, not 0, if c is greater than 1, so this is what we're going to refer to as our c. So here we have a value that's greater than 1 over here with that f of x equals 2x squared. And what did we do? Then y equaling c times f of x is a vertical stretch, is vertically stretched, excuse me, get my tenses together, by multiplying each of the y coordinates by c. So that's what we just did. Here's my c value. I multiplied all the y coordinates by c. Here's my c value. I multiplied all the y coordinates of the original by c. Now, if c is less than 1, then y equaling c times f of x is vertically shrunk. So we squash it by multiplying our y coordinates again by c. So that's how you do that with that number out front. Again, it's just an approximate, well, it's nice to just be able to kind of sketch the graph and not get exact points, but when we do try to get exact points, we do have a method to do that. All right. And our final one before we kind of throw it all together is when we're looking at a horizontal stretching or shrinking, which this is the most difficult that we have, but unfortunately we don't kind of look at this too much, but it is good to know. So we're going to let f be a function and c is a positive real number. What we want to do by shrinking this, okay, it's different than multiplying our y-coordinates by c. Now we're going to be looking at doing some things with our x-coordinate because what we now have is y equals f of c times x. And I can prove all this for you, but I'm just going to kind of give you the idea of what we need to do to get there. So if c is greater than 1, just like what we had before, then our graph now where our c is on the inside, grouped with our x, is horizontally shrunk this time by dividing each value or of our x-coordinates by c. So now not multiplying our y-coordinates by c, we're dividing our x-coordinates by c. And if c is less than 1, this kind of seems opposite. You would think that it would be similar to the one above, but it's not. Then it is horizontally stretched by dividing each of the x-coordinates by c. Again, this is the hardest one that we have. All right, so the easiest way for me to do this with you guys is here I have this graph, okay? I have points along the way, so I'm going to put those points, each of those 1, 2, 3, 4, 5 points in a t-chart. Okay, we have negative 2, 0. We have 0, 3. We have 2, 0. We have 4, negative 3. And we have 6, 0. And I want to have a c times x here. Our c is 2 this time. So if it's greater than 1, we're going to shrink it down, and we're going to do that by dividing our x-coordinates by c. c is equal to 2, so I need to divide this by 2, which gives me negative 1. Divide this by 2 gives me 0. Divide by 2 is 1, divide by 2 is 2, and divide by 2 is 3. Now I have 5 points to plot, and I get my new graph. Negative 1, 0. 0, 3. 1, 0, 2, negative 3, and 3, 0. So what we have here is that we vertically shrunk that, or excuse me, horizontally shrunk that, okay? Where it's kind of like an accordion in a sense. You kind of squashed it together in a small area. We've kind of just molded these in here together. All right, now, so that's the new graph of that. And notice I don't tell you what f of x is equal to. This is the notation and this is the function. So you have to get from what they're asking me here to get that new graph. That's kind of hard. All right, again, I'm going to do the same here and write these 5 points. Negative 2, 0, 0, 3, 2, 0, 4, negative 3, and 6, 0. Okay? So this time, I'm going to have c value that's less than 1, so we're going to stretch that horizontally by dividing each of our x-coordinates by c. c this time is 1/2. Well, if I divide by a fraction, dividing by a half is the same as multiplying by 2 because I have to multiply by the reciprocal. So the reciprocal of 1/2 is 2. Now I'm going to multiply each one of these by 4. You can throw into your calculator, multiply by 2 to get negative 4. You can divide by 1/2 in your calculator and you're going to get the exact same values. But I'm going to just do it by a shortcut of multiplying by 2. So if I do that, now I've kind of changed my coordinate system here, so it'll look a little bit different. But if I do that, we're going to have negative 4, 0, 0, 3 would be here. Then I have 4, 0. Then I have 8, negative 3, which would be here. And then I have 12, 0, which would be about there. Okay, so if I connect those, then what I've done is now vertically stretch that along the axis. If we actually had the same coordinate system, you could see that that was being stretched horizontally over that x-axis. Okay? All right, so now here comes our culmination. Here's the last of what we have. working through each one of these and figuring out what happens and how to get there. Okay, so let's put it all together. Given this function, we're going to do one of these, and then we're going to get back into our original functions that we have. So I have these points, and I need to do these transformations on that graph, okay? So first off, if we look in this general form, I have an x plus a c value, so this is a horizontal shift. Taking the opposite of that means I'm going to go left by 1. This is my vertical shift, plus or minus at the end, so that means I'm going to go down by 2. So going back to this graph, if I go to the left 1 and down 2, that new point is going to be at -5, -2. Take our next point, we're going to go left 1 and down 2. Now gives me the point -3, -4, -3, -4. Go to the left 1 and down 2. Gives me the point -1, -2. Left 1 and down 2 is now the point 1, 0. And left 1 down 2 gives me the point 3, -2. So on our coordinate, this is the transformation f of x plus 1 minus 2. Okay? Now, here's one where we have the c out front. That is going to be our vertical shrinker or vertical stretch. And in this case, it's going to be a shrink because I have a 1/2, which is less than 1. I'm going to go ahead and plot these points on -4, 0 on a t-chart. So all I'm doing is stealing all these points from our original graph and just putting them all on a t-chart. Now, this tells me I have to multiply the y value by c. But this also says I need to reflect. Now, you can actually do a 2-for-1 deal. I'm going to multiply the y value by all of that. That negative means I'm going to end up flipping it over the x-axis. But we're going to work it out by multiplying all these y values by -1/2. Well, 0 times anything is still 0. Multiply -2 by -1/2 gives me a 1. This still gives me a 0. This gives me a -1, and this still gives me 0. So now, just by multiplying, we now have our 5 new points, -4, 0, -2, 1, 0, 0, 2, -1, and 4, 0. So what we have done is done that vertical shrink. We squashed it down a little bit for that, okay? So I know those when you just have a graph and you're given the function and the transformation in terms of these function forms like this, those are a bit harder, but go back to the original concepts and it will work. All right, let's check this guy out. This guy has an x squared. So if you want to do kind of those t-charts, -2, -1, 0, 1, and 2, when we square the originals, we get this, okay? But more importantly, looking at this function, what did I do? This inside is grouped with my x, so I got to take the opposite of what I have here, and it's going to be a horizontal shift by the left of 2. And we also have a negative here, so we're going to reflect over the x-axis. That's out front, completely out front. So we're going to reflect over the x-axis. So this original parabola, I'm going to start always at the origin. I'm going to move left 2. And I'm going to, instead of the parabola going up like this, it's going to end up doing something like that. Okay? So this is going to be my new turnaround point. So from here, you can kind of do this pattern, but you're knowing it's going to be reflected. It's going to come down here somewhere. Okay? So if I go over 1, then I'm going to have to go down 1 to get this next point that's right here. Okay? And we're going to go left 1 and down 1. So again, it's kind of a nice pattern. You go over 2 and down 4 this time. So a lot of times I just work with these 3 points, and then I'm going to be able to mirror it because I know that it is symmetric. And here gives me my upside down parabola for that one. Okay? If I look at the next one, 2x squared minus 4. Well, let's see. This -4, let's start with that. That's a vertical shift where we're going to go down by 4. We have our original parabola, but the original parabola means that I have to multiply each one of those values by 2. That's our c that's out front. So this is going to be our vertical stretch. So again, I'm going to start with -2, -1, 0, 1, and 2. So when I do 4, 1, 0, 1, and 4, which are the original points, go ahead and just double each one of those, and then we can kind of work from that new vertex after we shift it down 4. So I'm going to double, make that 8, 2, 0, 2, and 8. Now, let's get our original point. There's no horizontal shift here because I don't have anything grouped with my x. So I'm going to go down 4, and that's going to give me my new point. Now, just work with these guys right here. The original 0, 0, that's kind of the new 0, 0. But instead of going over 1 and up 1 like we do on the original, let's go over 1 and up 2 from that vertex. Now, if I have one here, then I've got a matching point on this side because we are symmetric. From here, to get the next point, that means I'm going to go from that vertex over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8 would give me this guy. But I am symmetric, so that means if 2 over here, I go 2 over here, and now I have this point, which gives me my vertically stretched parabola in that sense. So again, making use of that original chart, a lot of times I do just these points and then mirror it over to get the others. Okay? All right, let's look at our original square root function. Y equals the square root of x. If you go back on the very first page, we looked at 0, 1, and 4. Square rooting each one of those gives me each one of these values. So the original 0, 0, in our new function, there is a number grouped with the x inside. That's my horizontal shift. Take the opposite of what I'm looking at. We're going to go to the right one. And this is my vertical shift, so that means we're going to go up 3. So if the original point is at 0, 0, I'm going to go to the right one and up 3. That gives me this point. Now, from that point, you can go over 1 and up 1, and over 4 and up 2. Or you can graph this point 1, 1. That means I'm going to go right 1 and up 3. Gives me that point. Either way works. You figure out what process it helps you. I usually do this. From the original kind of point, we would go over 1 and up 1 from the origin. And then here we're going to go over 4, 1, 2, 3, 4, and up 2. That gives me my new point and my graph. Okay? All right. We're getting close. We got 4 more. And if at any time you need to pause this, go ahead and do so. If you need to come see me sometime or set an appointment, I know this is a little bit tougher section to have to conquer online. It's a lot of visual stuff. All right, we have an absolute value. We have an absolute value, which is a V shape, don't forget. And we have a C value out front that is actually a -2. That 2 is going to shrink that, stretch that vertically. And that negative is actually going to be a reflection over the X. So we're going to reflect over the X. This is going to stretch it vertically. And this X minus 2 inside, we're going to take the opposite of what we have. That's our horizontal shift, so we're going to go to the right by 2. Now, the original T-chart of absolute value were these, 2, 1, 0, 1, and 2. So I'm first going to just do the shift by the right of 2. So if I go from the origin, which here was our original, I'm going to move to the right by 2, and that's going to be my new point. But now, let's go ahead and take all those y values and multiply by -2. So I get, I get -4, -2, 0, -2, and -4. So that means, and again, I'm going to kind of work with just these here. From the new turnaround point, remember it was here. Now, if I just moved it to the right, it would be here. But now I'm going to reflect it over the X, so I'm going to have something that goes down here. And this is going to tell me I'm going to go from my 0, 0, that doesn't change. We're going to go to the right one and down 2. Right one, down 2. Now, there is symmetry here, so that means that this point is also going to be on there. Go to the right 2 and down 4. Gives me this new point, which also means that this point is on there as well. Now, you can keep going, but you don't have to. That's going to give us our graph. Okay, so that original T-chart is going to be very, very helpful. Okay? All right, here we have an x cubed. So going back to the front, looking, looking at that original x cubed, choosing -2, -1, 0, 1, and 2. This one is not symmetric over the y-axis like the last ones. So I'm just going to look at all of those points. And if you remember, now notice here there's no shift with my x to the right or to the left because there's nothing grouped with the x, nothing plus or minus at the end, so no vertical shift up or down. All that we have is that c value. So if we have a c value that's out front, all we have to do is multiply the y values by that c value. So 1/4 of -8 is -2. 1/4 of -1 is -4. 1/4 of 0 is 0. 1/4 of that is 1/4, and 1/4 of that is 2. So now I have these new points, -2, -2. Then I have -1, -1/4, which is about there. Then I have 0, 0, 1, 1/4, and then 2, 2 would be this guy right here. So what I have in that x cubed is a vertical squiggle. So what I end up having is here, and I flattened it around, and that 1/4 represents that vertical shrink. So I've kind of flattened it and squashed it from the original that we had. Okay. We incorporate a 1/2 with that cube now, but now we have a horizontal shift to the right by 2 and a vertical shift down by 1. And we're going to take half of those y values. So again, let's do a t-chart of the original. The original y values are -8, -1, 0, 1, and 8. And we're going to take half of that. So half of this is -4, -1/2, 0, 1/2, and 4. But we're going to do that from the new point at 0, 0. That is shifted by 2 and 1. So we're going to go to the right 2 and down 1 gives me this point. Now, this is acting as my 0, 0. So that means right here on these, we can mirror image it also, but over 1 and up 1/2. So from there, over 1 and up 1/2 would give me this. Now, this guy would be to the left of that by 1 and down 1/2. So I can also mirror that kind of, this is an odd function if you remember that. Here we're going to go from this turnaround point, we're going to go over 2 and up 1, 2, 3, 4, which gives me that one. And from here we're going to go left 2 and down 4. 1, 2, 3, 4 gives me this one. And so now I can connect each one of those for my x cubed, and that gives me my graph. Okay, so please make sure you use those t-charts if you need to. All right, and our last one is this cube root of x. Again, we don't see this one as much, but there are probably some problems with it. The cube root of x, if you recall, was this guy. Our original points were from -8, -1, 0, 1, and 8. And this is a -2, a -1, a 0, a 1, and a 2. And so basically, this transformation for this equation grouped with our x, this is going to give us a horizontal shift to the right by 1. Remember, take the opposite of that sign. Take this sign as is, means that we're going to go up by 2 on our vertical shift. So if I'm originally at 0, 0, if I go over 1 and up 2, that gives me that new point. If I then have the point 1, 1, go over 1 and up 2 gives me that new point. Then we have the point 8, 2. 8, 2, go over 1 and up 2 gives me that point. Then I can also, from -1, -1, go over 1 and up 2 gives me this point. And -8, -2 for that point, go over 1 and up 2 gives me this point. And so if you notice, we do have that sideways, whoops, I'm off again a little bit, but we do have that sideways squiggle with those points that gives us that transformation. So, I know this is a really long one, but it is an important section that you want to make sure that you understand. Please make sure that you practice that and master the art of transformations. Until next time.